Hi everyone, this is going to be a tutorial on developing a set of suites that start to optimize the building performance. And I'm going to show you with a few new tools how to go about doing this. With the version 2 of the dashboard, in addition to the year tab that we already looked at in the last tutorial, you'll notice that the input-output summary and the input-output example are a little bit different. Instead of having your sensitivity analysis go across the top here, there's a baseline and then a whole bunch of blank lines. And you'll see as we go through this tutorial that there's a specific way that I have in mind for you to use this. You'll also notice that the benchmark and hand calculation models and utility bills are gone now from the bottom. So because this is a performance model, what I want you to do is, relative to your baseline, compare what improvements or what changes will make a difference in the building performance. So starting out here, I'd like you to begin with the baseline building that has in it whatever optimized mixed mode operation you found. And this should reflect how the building's actually operated. Actually, if it doesn't have mixed mode operation, then don't include it. But if it does have ventilation, natural ventilation, or economizer mode in the actual building, then that is going to better approximate how the building actually functions, and I'd like you to use that now as a new baseline. So I've taken my the mixed mode operation baseline that I developed in the last tutorial, and I've renamed it as 30 baseline 02, and I'm going to open that in the IDF editor. And before I actually go through this, what I'd like you to do in developing at least two different suites of improvements is to first take a step back and discuss as a team the fundamental strategies you think will improve the building performance. And this is going to involve really using your brain. It should be a really fun exercise, I hope. And sometimes I find that it helps to sketch through different options, to have a plan or an elevation and consider what the building will look like with the different options. So I've actually included for you in the drive folder, I've included an example for you to show the type of analysis I'm looking for here. This is a former student of mine. Actually, instead of just doing 2 suites, they did 5 suites. But they took their base building and then imagined what it would be like with different types of constructions and different assemblies, going through thinking about their base building and what it represents, and then changing it to be more like a thermos, more like a combination greenhouse thermos pyramid, and then also looking at some different materials, straw bale, shading and glazing, and ventilation. And they did a very nice job of representing both what the existing conditions are like. Here's a typical wall section, for instance, and here's how it functions, both in terms of comfort and energy. And then if we add more insulation, here's aesthetically what the differences are, how it feels to be in it, and what changes, or how things change, how the envelope reacts. And so I would encourage you to think about your model in these terms. So if I'm taking Worcester 214, for instance, I would start by discussing with my team, what is the building like now? As we did in class, we sort of came to the conclusion that it's kind of a ventilated pyramid. And then how could it perform better? So one idea, just throw this out there, is that what if we insulated it? What if it were more like a thermos? So it was kind of like a ventilated pyramid thermos, which would entail a few things. One would be increasing the insulation. Another would be possibly improving the glazing. Another would be to weatherproof the envelope so that there's less infiltration. And maybe we could also improve the fan performance by using heat recovery fans or just using fans that are localized. I'll just say localized fans here. So we're losing less, there's less leakage through the ducts. And then there's some other things that you could probably do. So that would be sort of a few things that are envelope related. There's probably also a good amount that are internal load related. So we could probably reduce the lighting energy and probably the equipment energy by installing better appliances and computers. And we know already that heating is a big deal for Worcester, and so probably improving the heating performance, heating system would also be helpful. So what I'd like you to do is kind of build up this suite, write it down, and then approach modeling it. And the way that we're going to model this, or the way that I'd like you to model this, is to take your baseline, and then in the last set of analyses, you took, in sensitivity analysis, you took one at a time and tested each one. In this case, though, what I'd like you to do is test it cumulatively. So we're going to kind of step through each of these improvements and keep sort of improving them, one based on the last model. And so let's start inputting now, actually, what my specific improvements will be. So for insulation, I actually have already thought through this a little bit. So for insulation, I'm going to add a foot of insulation, so 300 millimeters, and I'm going to enter this under my exterior walls here. Oh, here's a tip, by the way. If you're if this is sliding down and you can't see anymore what's up there, you can highlight the row that you want to be able to see, click View, and then click Split. And this will introduce these panels that you can move like so. And now I can make sure I'm always seeing that top row and this side row as I scroll across. So I've got a 300 millimeters of added insulation. I'm also going to add some, for the windows, some passive solar glazing, so probably triple glaze with a pyrolytic coating. I'm going to improve my infiltration by adding weatherproofing, both weatherizing the envelope and around the windows. I'm going to have simulate localized fans by eliminating ducts. That's going to be reflected in my fan pressure rise or pressure loss. What else can I do? And then for the lights, I'm going to add LED lights in my add LED lights, and then I'm also going to add Energy Star equipment here in my equipment category. And last one, for the heating system, I'm going to do a relatively large retrofit here and install heat pump radiators. So I'm going to dramatically improve my heating coefficient of performance that way. So these are the changes I'd like to make, and actually, yeah, those are some good changes I'm going to go through, and I want to show you how fast and easy this can be to model quickly. So I'm going to go to Energy Plus and navigate to my new baseline, and in here I'm going to edit this and change it to File, Save As, 31 Insulation, and I'm going to change my wall insulation to 300 millimeters, and I'm done with that one. The next improvement I've got is improved glazing. So I'm going to switch to the passive solar glazing here, which is in the constructions again. I'm going to save this as 32 glazing, and I'm going to change the glazing to, I'm going to use a really good one here, triple clear, low E, high solar heat gain coefficient wood. So that should be a low U value and high SHGC. And then I'm also going to change my blinds here to do the same thing. I'm going to save that. The next one I've got is weatherproofing, so infiltration. And I'm going to go down. I'm going to save this. Remember to save as you go. This is really critical. 33 infiltration. And I'm going to go down to my infiltration object and change this from 1 to 0.1 and save. The next one is localized fans. So I'm going to use no ducts. And if I go to the model inputs calculator that you got last week, I can go to the fan tab and see that the fan pressure drop for localized ventilation units is 300 pascals. And in Energy Plus, I can go to my fan and change it to 300 pascals. Here. I'm not using this fan, so I'm not going to bother to change it. I'm going to save this as 34 fans. And then back to the dashboard, LED light. If you remember back to the initial energy model template, there was a tab here called lighting, and in this one you can see the difference that LED lights would make if you have good quality LED lights. It's about 100 lumens per watt. If you're replacing incandescent lighting, which is your standard sort of 100 watt light bulb, that is about 6.5 times more efficient, the LED is. In the case of Worcester, most of the lights in the computer lab are linear fluorescent, so it's only about 1.7 times more efficient going to LED. So going back to my IDF editor, I can go up to my lights, and instead of 20 watts per square meter, I could make that, let's say 12 watts per square meter, and save this as 35 lights. Then the next one is equipment. I'm going to use energy efficient equipment in here, so instead of 2000 watts I'm going to change this down to 1500 watts, and I will save this as 36 equipment. And then the last thing is the heating system, and to model this a better heating system with heat pumps and radiators, I can actually post-process that using the COP in the file, which is this right here. So actually, before I forget, I should probably input these guys. I don't remember offhand what I had them set at before, but I'll do that and then come back. Okay, so I've entered all these and these guys, and now the only thing left to do is to run the simulations, and you guys all know how to do that. You can browse to each one and then run it with your correct weather file. When you simulate, make sure you're checking for errors for each one, and then For this assignment, you're going to want to look primarily at the tables files. So again, copy the table into here, get the end use from here, and then input that into the columns at the bottom here to get an EUI, and then your graphs will populate. And I've gone ahead and run all this, and just like the cooking shows, an hour later we've got the this nice progression of energy efficient measures as they go from the baseline to insulation to glazing, so on and so forth. And then this one over here would represent the entire suite, because these are all cumulative. Interestingly enough, you can see that this wall insulation, which was my first thing to make my thermos, had some effect. It changed, it reduced the heating a fair amount, but not a huge effect, which is surprising. You can see that the triple glazing made much more of a difference, and the infiltration made even more of a difference. So those were some very interesting synergies. It could also be possible that if you reverse the order in which you do these, so maybe do the infiltration first, and I did the glazing second, and then the wall insulation, you'd see a much bigger difference in the percent change from one to the other. So it's another thing to experiment with if you have the time. But and actually, you should see also down at this end, as I reduce the lights and the equipment, you also see some pretty dramatic changes that will also then impact the heating and cooling again. Now, one thing that is true is that when you have the heating, cooling, process loads, equipment, hot water, ventilation, everything in this graph, it sometimes can be difficult to see what changes are responsible for what. And so this is one method of visualizing the data. But you can also copy this graph. Let me do this for you. I'm going to copy this, and I'm just going to do this off to the side for a second. I can copy this and delete the things that are kind of not of interest to me. So the process, equipment, lighting, heating, hot water, I'm just deleting these as I go, and if I can't, it's too small to actually select, I can go up to Format and then go down to Hot Water and delete it. And as we do this, I'm going to delete the ventilation as well. You'll notice that the vertical scale is changing, but you can also see now a lot better the impacts on heating. It's sort of more, it emphasizes the importance of these different things, and as a result of it being heating dominated, I can't really see so much what's the cooling impact. So I could further copy that and paste it, and then delete the heating, and then I would see a lot better what impact things have on the cooling. So, for instance, this move from triple glaze to infiltration dramatically increased the amount of cooling, but it's actually not. It's relative to itself. It's not a large number in any case. So so that could be a useful tool to analyze the impacts of the different measures. Another tip that might be helpful for you right in Excel is to use some lines to annotate the graph. It'll help you to see things a little better. So I can go up here to Insert and then Shapes, and then there's a line shape here, and I can draw this across, maybe change the color to something, and maybe change the weight to something a little thicker. There we go. And you can do this in InDesign as well, but I like to sometimes do this right in Excel, so as I'm working I can see what I'm doing a little better. So if I just draw a line across where the baseline is, I can see a lot better the relationship, how much energy I'm now saving for each of these. And I can copy this by clicking on the shape, pressing Control C, and then Control Control V and doing the same here so I can see the relative impact right in the graph. So I hope those tips help, and I hope this is a fun exercise for you. After you finish the first suite, please then go on to your second suite and third and fourth and fifth, as many as you want to create. You must create at least 2, but it's a good exercise to try to create a few different ones. It'll get your mind thinking in different ways. And one piece of advice is to, when you conceptualize it, I've done in this case kind of a thermos slash chicken coop slash pyramid. Another way of approaching this is, rather than a sort of hybrid, is to reinforce some of its intrinsic properties. So Worcester is right now a chicken coop pyramid, but I could choose one or the other and make it more like a pyramid and less like a chicken coop. And so reduce the infiltration, reduce the ventilation, but increase the thermal mass and increase the shade, and see what happens. Or I could even reduce the window to wall ratio using Legacy Open Studio, and it's really about trying to check to see what happens, what's going to be a useful strategy as you move forward. Keep in mind that we're going to continue to work with these suites moving forward. I hope that you'll come up with some really effective ones this week, and then next week we're going to work with machines and renewables in order to fine-tune them even further. So good luck with this, and bring your questions to class.